And when we turn to the other side of this scientific method equation, we do lots of observations, but then we do all sorts of sophisticated things with them analytically and logically. The pragmatist will also emphasize that this whole set of processes has its own fallibilities and potentials for error built into them, and we can never be sure that we have bracketed all of those successfully. Now, there's a big complicated story here, but let me just give you a quick and dirty overview of it. Suppose we focus on logic, and we just say within logic there's a fairly standard division between deductive logic and inductive logic. And we'll do a little sidebar. What do we mean by deductive logic? Well, one classical account of deductive logic is to say that deductive logic operates in terms of generalities. So we will have very general, abstract, or universal types of propositions, right, or sentences, and we'll derive other generalities from them, or we'll apply those to particular instances. So I might say all human beings are mortal, Socrates is a human being, therefore. So take the generality, all human beings are mortal, apply it to a particular individual, Socrates. He is a human being, therefore, the conclusion that follows deductively is that he is mortal. And there are lots of different patterns of deductive reasoning. If we just try some abstract patterns here, I might say, for example, that all of the humans, right, are mortal. Socrates is human, so therefore it follows that Socrates is mortal. And that's perfectly fine. I might have as another possible pattern, I might say that all of the A's are B's, all of the B's are C, and then as a logical deductive derivation I can conclude, therefore all of the A's are C. And that's a beautiful thing, perfectly valid argument from a deductive logic perspective. Or I might also try another pattern over here. I might say all, let me just change the letters a little bit here. The L are G, all the D, right, are G. Okay, and then ask what follows from that logically, and put down as a candidate, therefore all of the L are D. All right, so I've got a bunch of abstract patterns up here. This one's fine, give it a check mark. This one's also fine, give it a check mark. But this one, though, as it happens, is bad reasoning. That's invalid reasoning. And like these two here, all humans are mortal, that is true. Socrates is a human, that is true. This conclusion follows necessarily, and if these two are true, this must be true also. Same thing holds here. If all of the A's are B, if that's true, and all of the B's are C, that's true, then given this pattern of reasoning, it follows necessarily that this conclusion that all of the A's are C necessarily is true as well. It's not true in this particular case here, and so if we did some substitutions, we can see that. If I said, for example, all lawyers are graduates of college, say, well, that's true. All doctors are graduates of college, that's also true. It does not follow, though, even though those two are true, that all of the lawyers are doctors, right? That conclusion is false. There might be some lawyers who are doctors, right, and vice versa, but we have two true premises here, and using this pattern of reasoning, we end up with something that is false. That's an indication of bad deductive reasoning. So the point of then doing deductive logic is to sort out all of the possible ways that we can combine premises to try to derive conclusions, figure out which ones are truth-preserving or which ones are examples of valid reasoning, and make sure that we train ourselves to avoid the ones that are not truth-preserving or are invalid, right, forms of reasoning. Okay, and that's a very valuable thing for people to learn methodologically, particularly as the kinds of things that they're trying to figure out as adults becomes more important, and so logic can be a very important part of the educational process.